Okay, we're starting off section 1.5 with the point slope formula. I don't care about the point slope formula. You can learn it if you want to. I don't think it's necessary because you can write the equation of a line given a point and given the slope, just like we did in the last lesson. You don't need a formula for that because you know how to do it. So this problem, we already did it, and you do it that way. I'm fine with that. I don't really mind whether you know the point slope formula or not. So don't worry about that. Do this kind of problem the same way we did it in the last lesson. Same thing with the the point slope formula when you're given 2 points. It doesn't matter to me either whether you learn the point slope formula. To find the equation of a line, you just need the slope and the y-intercept. That's all you need. So you would need the slope, m. So remember the equation of a line, y equals mx plus b. So you need the slope, you need the y-intercept. They give you 2 points. You can figure out the slope by using the slope formula. You would say m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And so you would have 8 over negative 5. So your slope for this line is negative 8/5. So negative 8/5 for your slope. And you would plug that in for m. And you would say y equals negative 8/5 x plus b. And then to find b, you just plug in one of these points. Doesn't matter which one. And so for y, I would put negative 6, and then I've got negative 8/5. And for x, I would put in 4. And then I'm just going to solve for b, get b by itself. So negative 6 plus 32 over 5 is equal to b. And so if you add these together, that's negative 30 over 5 plus 32 over 5, and that is just 2/5. So b is 2/5. So the equation of the line is y equals m, which is a negative 8/5, x plus 2/5. So you don't need the point slope formula to do that problem. You can do it exactly the same way we have done it before. Okay, parallel lines have the same slope. They have the same steepness. So parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. So when you have a slope of one line and there's a line that is perpendicular to that line, that means it is at right angles with the other line, then the slope will be the opposite. So it will be the opposite sign, and it will be the reciprocal. So it will be flipped upside down. And this is what that looks like. So this is the relationship. So if you want to write an equation of a line passing through the point negative 4, 1 and parallel to the line defined by x plus 4y equals 3, you just have to know what the slope of that line is, x plus 4y equals 3, and you'll know that the line you're trying to write the equation of will have the exact same slope because they are parallel. So here, if you solve for y, you're going to have 4y equals negative x plus 3. If you divide through by 4, you're going to have y equals negative 1/4 x plus 3/4. And so the slope of that line is negative 1/4. So the slope of the line parallel to it will also be negative 1/4. So I'm going to write this equation of a line. Negative 1/4 is going to be the slope, and I just need to find the y-intercept using this point. So I'll plug in 1 for y and negative 4 for x. And if I do that, I'm going to have 1 is equal to 1 plus b. And so b will be 0. And the equation of the line that I'm talking about, the line that passes through the point negative 4, 1, and is parallel to that line x plus 4y equals 3, is just going to be y equals negative 1/4 x. Okay, now we're going to write an equation of a line that is perpendicular to another line. So write an equation of a line passing through the point 2, negative 3, and perpendicular to the line y equals 1/2 x minus 4. And so I can see clearly that the slope of that line is 1/2. So the line I want to write the equation of is perpendicular to that line, which means that the slope of the line I'm going to write is going to have a slope that is the opposite reciprocal of that. So opposite is going to be negative. And reciprocal, you're going to flip it upside down. So 1/2, the reciprocal of 1/2 is 2. So for my line, m is going to be -2. So my line is going to look like this. Y equals -2x plus b. We got to find the y-intercept, and to do that, we will just plug in this point that is on our line. So y would be -3, x would be 2, and I'm trying to find out what b is. So I'll add 4 to both sides, and I'll get 1 for b. So my final equation is going to be y equals -2x, because the slope is -2, plus 1. Okay, using a linear function in an application. An application just means taking some math idea, some concept, and applying it to some uh, situation. Could be a real life situation, could be a video game situation, who knows? But it could be any kind of situation where you can take this math that you know and apply it to something else. So a family cell phone plan costs $130 a month for 4 lines. Each additional line costs $19.99 a month. So part A says write a linear function to model the monthly cost, C of X, in dollars, of a family plan for X additional family members added beyond the first 4. All right. So you're writing this function, and it's going to be C of X, the cost, where X is additional phone lines. Okay, past the 4 you get for 130. So the cell phone plan costs 130 a month. Just that's the way it is. We don't have to multiply that by X or anything, because that is the cost of the first 4 lines. Our X represents the number of phones beyond the first 4. Okay, so the cost per month is going to be that $130 that you have to pay for the first 4 lines, plus $19.99 for each additional line. The additional lines, there are X of them, so that would be $19.99 times X. And then part B says evaluate C of 3. So what would be the cost? What would be your bill if you got 3 extra phones? So C of 3 means what's the cost of having 4 lines, like the plan is, plus an extra 3. And that's going to be 130 plus $19.99 times 3. That's going to be $189.97 per month for basically 7 phone lines. Okay, a linear cost, revenue, and profit function. All right, so we're going to look at what these 3 things mean. What is a cost function? What is a revenue function? And what is a profit function? All right, the cost function is just how much it costs to produce X items. All right, so a linear cost function would look like this. C of X is equal to mx plus b, where m is the variable cost per item and b is some fixed cost. So the fixed cost is something that doesn't change no matter how many items you produce. So if you have to rent a building, it doesn't matter how many items you produce that month, you're going to have to pay the same amount no matter what. Okay, so that's your fixed cost, B. Your variable cost, M, is how much it costs to make each item. So you got to figure out how much money you're going to have to spend every month. You're going to figure out, okay, I have to spend M dollars for every item I make per item, so MX. And then I have to also add the rent or whatever that fixed cost is to that. So that's a cost function. A revenue function, all that function tells you is how much money you made. It doesn't care anything about what anything costs. All the revenue function tells you is how much money do you make, R of X. And so that is just going to be the product, the number of products, X, times the price per item. How much are you charging for each one of those products? And so the money you will make will be just that price times the number you sell, so PX. Profit function is equal to the revenue function minus the cost function. Revenue means the money you make. All right, so let's just look at an example. Might make more sense. All right, so at a summer art show, a vendor sells lemonade for $2 a cup. The cost to rent the booth is $120. Furthermore, the vendor knows that the lemons, sugar, and cups collectively cost 50 cents for each cup of lemonade produced. So first of all, part A, we're going to write the cost function. This will be a function just about how much I'm going to have to pay to sell this lemonade. What is it going to cost me? All right. So first of all, the costs are renting the booth, $120. Doesn't matter how much lemonade you sell, whether you sell any or not. You're going to have to pay that $120. So C of X, our cost function, is going to be that 120 is going to be our B. That's going to be what we have to pay no matter what. And then for every cup of lemonade, I'm going to have to spend 50 cents to make that cup of lemonade. So each cup, there's X cups, so 0.5 or 50 cents times the number of cups of lemonade I make. So this is my cost function. This is the money I have to pay to do my business. So 0.5, 50 cents times X, the number of cups I'm making, plus $120 for rent. That's the cost function. Part B, write a linear revenue function. This is just about the money I'm going to make by selling X cups of lemonade. I'm charging $2 per cup, and so that's what I'm going to make. R of X is going to be $2 times the number of cups I sell, and that number is X, so 2X. That's the money I'm going to make. $2 per cup. Part C, write a linear profit function for producing and selling X cups of lemonade. The profit function is equal to the revenue, the amount of money I make, minus C of X, the amount of money I had to spend. So all I'd have to do is just subtract 2X minus the cost, 0.5X plus 120. So the profit function, 2X minus 0.5X is going to be 1.5X, and then minus 120. So that's going to be my profit function. Part D, how much profit will the vendor make if 50 cups of lemonade are produced and sold? So the profit function, I'm going to put that 50 cups in there for X. So I'm going to put that 50 cups right there. So 1.5 times 50 cups of lemonade minus 120. That's just going to be 75 minus 120. And that is actually going to be negative $45, which means I'm not going to make any money if I only sell 50 cups of lemonade. In fact, I'm going to lose money if I do that. So there's no point in even doing this thing if I'm going to lose money. So not a good idea. All right. So no profit, actually a loss. Okay. For part E, how much profit will be made by producing and selling 128 cups of lemonade? So the profit function, again, is 1.5x minus 120. So 1.5 times the number of cups, 128, minus 120. That's going to be $72. I'm going to make a whole $72 by doing all that work. But maybe you just want to have a fun time at this art show and you don't really care whether you make money or not. All right. So final question, determine the break-even point. The break-even point is when you don't make a profit, but you don't have a loss either. It is when the cost is equal to the revenue, when C of X and R of X are the same thing. You spend C of X, so C of X is 0.5X plus 120, and R of X is 2X. So if you solve for X, you'll find out how many cups you need to sell to break even. So if you subtract 0.5x on both sides, you'll have 120 is equal to 1.5x, and divide both sides by 1.5, and you're going to have 80 cups. So you have to sell 80 cups of lemonade in order to break even. Here is the picture of what's going on there. So the blue line is your cost function, 0.5x plus 120, and the purple line is your revenue function. R of X equals 2.00x. And so graphically, you can see that when those two lines cross, when they have the same value, is right there where you have made 80 cups of lemonade. That's where you break even. That's where the revenue and the costs are the same. And so if you look at the graph of the profit function over here, the profit you make for making a certain number of cups of lemonade is shown in this picture. Right? If you don't make 80 cups, you're at a loss. You are making less than $0. Once you hit 80, everything else becomes profit and you start actually making a profit. So you're above zero. Once you hit 80 cups, you are making a profit. All right, so writing a linear model to relate two variables. The data shown in the graph represent the age and systolic blood pressure for a sample of 12 randomly selected healthy adults. All right, so you have your age across the bottom, that's your x-axis, and the blood pressure is the vertical axis. So you can see as you get older, your blood pressure does tend to rise a little bit, even if you're fine. So suppose that X represents the age of an adult in years and Y represents the systolic blood pressure in millimeters of hemoglobin. Use the points 21,118 and 51,130 to write a linear model relating Y as a function of X. All right, so you're saying the blood pressure is Y and your age is X. Those are the vertical and horizontal axes on this graph. And so we're just going to write the equation of a line given 2 points, 21,118 and 51,130. To do that, we will just find the slope of the line, and we will use the slope formula to do that. So we will write M, difference in the y's, so 130 minus 118, over the difference in the x's, 51 minus 21. And if you add that all up, you've got 12 over 30, which is 6 over 15, which is 2/5. So the slope of the line would be 2/5. And then to find out what the y-intercept would be, we will just have to plug in one of these points into our equation. So it doesn't really tell us what to name this function. We could just call it function f. So f of x, where x is the age of the person, is going to be, the slope would be 2/5 x plus b, some b that we don't know yet. So we're going to plug in one of these points to find out what b is. And I'm going to jump down here. So for f of x, I'm going to go ahead and use this point right here. So f of x is 118, my y value, and then my slope is 2/5, and x is 21. And then I'm trying to find out what b is. 109.6 is my b. And so the function, that function, part A, is f of x equals, the slope is 2/5 x plus b, which is 109.6. So that's the function that represents what's in this graph. Now, for part B, it says interpret the meaning of the slope in the context of this problem. The slope gives you an idea of how quickly what is the rate of change of this line? I mean, does it shoot up really fast as you age? Not really. It just goes slowly, you get your blood pressure increases a bit as you age. So from age 21 to age 51, it goes up about 12 points. But I would say that the slope just tells us the rate of change, how quickly your blood pressure changes as you age. And it takes a while. I mean, it takes 30 years for it to go up 12 points. So that doesn't seem too drastic. All right, so it says use the model to estimate the systolic blood pressure for a 55-year-old. All right, so 55-year-old, that means you put in 55 for X. So F of 55 is going to be 2/5 times 55 plus 109.6, 131.6 millimeters of hemoglobin for a 55-year-old.